Lastly, we're going to take a look at the graph of y equals natural log of x. Recall we said before that f at x equals e to the x, and then the natural log function are inverses. So we're going to call f at x e to the x, and f inverse of x is the natural log of x. And so those two are inverse functions. We know from before that the graph of f at x equals e to the x is an exponential growth graph similar to the one for 2 to the x. So notice I graphed e to the x. Notice, by the way, e to the x passes the horizontal line test. It also is a function, so it passes the vertical line test. So f at x is 1 to 1, and therefore it has an inverse. If we reflect the graph of e to the x over the line y equals x, what happens is we obtain the graph of the inverse function, and we obtain the graph of natural log x. So notice e to the x is an exponential growth function, horizontal asymptote at y equals 0, passes through the point 0, 1. Notice the natural log of x, when I graph it, passes through the point 1, 0. Remember we said before we could interchange the domain and range, interchange the x's and the y's. The horizontal asymptote of e to the x on e to the x of y equals 0 becomes the vertical asymptote of x equals 0 for the natural log of x. So take a look at the graph and make sure that you're comfortable with what the graph of e to the x looks like versus the graph of natural log of x. Like we did before, we could actually compare some information about e to the x and the natural log of x. Notice e to the x has as its domain the reals, and likewise the natural log of x will have as its range the reals. So e to the x goes left and right forever, natural log of x goes up and down forever. Notice the range of e to the x, the y values, are the positive reals, everything from 0 to infinity. Notice that the domain of natural log of x will be the same thing. The positive reals will be the legitimate input values for natural log of x. Again, as I said before, e to the x has a horizontal asymptote of y equals 0, while natural log of x has a vertical asymptote of x equals 0. As I mentioned before when we were looking at the graph for e to the x has a y-intercept of 0, 1, and that really comes from the fact that e to the 0 equals 1. But the graph of natural log of x is going to have an x-intercept, and that's going to be at 1, 0, and that comes from the fact that natural log of 1 equals 0. And so e has the point 0, 1, natural log has the point 1, 0. One last thing, we could actually compare the graph of y equals log x and the graph of y equals natural log of x. If we do that, what you will notice is the log x does not grow as quickly. Natural log of x grows a fair amount quicker than the log x function does. But they both have the same shape, and they both contain the same vertical asymptote of x equals 0. Well, now you can go into the textbook and take a look at the problems for this section. Please let me know if you have any questions. The section really is very much about graphing and the behavior and asymptotes, and we'll discuss any of the problems that give you trouble.